It's a 5-acre underground installation built of thick welded steel beneath a mountain of solid granite to withstand a nuclear blast and deflect another 9/11. This all-seeing secret military fortress is our first line of defense. The making of Norad, now on Megastructures. It's one of the largest underground military command centers in the world, responsible for protecting the skies over North America, capable of monitoring enemy missiles around the globe, in charge of deterring terrorists in the aftermath of 9/11. And it's buried deep inside a mountain. This is Norad, the North American Aerospace Defense Command Center. Its state-of-the-art computer systems are linked to a worldwide early warning network of satellites, sensors, and radar. NORAD's mission is to track all top-secret intelligence transmitted from this sophisticated warning system. But its top priority is to use that intelligence to monitor the skies for incoming strikes against North America, assess potential threats, and coordinate a full-on military response, giving U.S. forces enough time to intercept or shoot down the enemy. Manning this megastructure, about 1,500 military and civilian employees from the U.S. and Canadian armed forces. They stand guard 24 hours a day, 365 days a year. Their motto: deter, detect, and defend. The idea for a command center of this caliber first emerges during the test nuclear arms race between the U.S. and Soviet Union. The need for NORAD becomes critically clear on August 29, 1949. When the Soviet Union detonates its first atomic bomb at a test site in Kazakhstan. America's position as the world's leading superpower is now in jeopardy. To counter the possibility of a nuclear threat from the Soviets, the United States and Canada form NORAD, which stands for North American Aerospace Defense Command. By 1958, NORAD's detection system relies on a global network of 57 radar sites planted above the Arctic Circle. It's called the Distance Early Warning Line, or DEW line. But NORAD's nuclear defense has an Achilles heel: the headquarters itself. NORAD is operating out of an old hospital in downtown Colorado Springs. Although it's close to other military facilities, including a U.S. Air Force base, the building, built in 1923, is a vulnerable target.
The commander at the time said, "There's a problem here. Anybody driving by with a bazooka could knock out this command center."
Military officials are forced to rethink the location of NORAD's headquarters. They need a protected site and a structure that's virtually indestructible. The Army Corps of Engineers is brought in to design this state-of-the-art military fortress.
We needed something that would be able to survive a nuclear attack, so that we could respond in kind, and the Soviets would know that, and therefore, hopefully, not attack us in the first place.
The Army Corps of Engineers was the mastermind behind the Pentagon military complex 17 years earlier, and America's top-secret missile silos in the 1950s. But the concept for this mountain complex comes at a time when engineering technology is relatively unsophisticated and limited. In 1958, computers, as we know them today, have yet to be invented.
The engineers used slide rules when they built this facility.
To get started, military designers proposed 3 different locations for the megastructure. They can dig out a concrete underground bunker like those constructed during World War II. They can erect NORAD inside an abandoned mine. or they can implement their most extreme design by carving out the inside of a mountain. 2,000 feet of natural solid granite protection convinced the engineers to build Norad deep within a mountain. The next step, find that mountain. They began the search in their own backyard, the Colorado Rockies. So engineers narrow the choice to two sites, the 9,423-foot Blodgett Peak and the 9,565-foot high Cheyenne Mountain. To select the best option, engineers must analyze rock core samples from each mountain. This process will determine which one offers the sturdiest protection for this unique underground megastructure. Helicopter pilots are hired to transport men, generators, and the heavy core sampling equipment to the sites. At each location, survey crews drill holes 3 inches in diameter and up to 1,600 feet deep. They use a borehole camera to photograph the rock structure inside the two mountains.
When they did the core samples in Blodgett Peak, they discovered that there was a lot of water compared to Cheyenne Mountain. They had much harder rock and much more consistent rock in Cheyenne Mountain.
Because it has a more stable rock structure, Cheyenne Mountain is selected as the future home of Norad. Engineers must now map out the construction project. Phase 1. Excavate tunnels, chambers, and reservoirs inside the mountain to create a 5-acre military installation, big enough to hold 5 football fields. Phase 2. Build a self-supporting city with 12 interlocking personnel buildings, its own water reservoirs, fuel supply, power plant, and ventilation systems. Like the Pentagon, this city will be open 24 hours a day. Staff will be stationed at roughly 800 desks and operate about 1,000 computers in an estimated 1,000 offices. Norad will have life-sustaining amenities like a gym, corner store, and cafeteria. Many of the building's exact details will remain under wraps due to the high security protecting this top-secret facility. But there's one characteristic that sets this headquarters apart from other megastructures: the ability to completely seal itself off in the event of a nuclear attack. Norad must be able to function and keep its personnel alive for 30 days without any support from the outside world. For Phase 3 of the Norad military complex, technical engineers will install a powerful scientific computer linked to a super surveillance system capable of monitoring missile activity around the globe. Norad is considered a Level 1 facility, and that means that this structure will have the highest operational security available. Building this military headquarters presents a challenge unlike any other that engineers of the time have attempted. 700,000 tons of granite must be excavated from inside the mountain, a weight equal to almost 4,000 commercial jets before construction of the buildings can even begin. By late September 1959, 2 years since the initial conception of Norad, construction crews hit their first obstacle. Engineers have positioned the North Tunnel entrance 1,000 feet above the base of the mountain. But the site is so remote, men and machinery can't access it by land. A 4-mile-long road must be planned and bulldozed before crews can start excavating the mountain. It takes more than 2 months to complete the road, from its beginning in Colorado Springs to the endpoint 1,000 feet up Cheyenne Mountain. But by November 1959, just as the new road is almost ready to transport crew and equipment, the entire project comes to a screeching halt. The roadblock this time? Money. Congress has not approved additional funds for Norad. At the start of 1960, with the threat of nuclear war still a frightening reality, America's answer, Norad, may never be built. Fire in the hole. Miners blast out tons of solid granite, risking an early grave for this stealth megastructure. Now back to Megastructures, Norad. November 1959. All across the U.S., Americans are living on the edge of a nuclear threat. The U.S. government is building what it believes is America's only viable solution. A top-secret military complex capable of seeing into every corner of the world. Construction crews have just enough time to finish the $1 million access road before the government shuts down the entire project. Estimates for the rest of the project are more than $26 million, and military officials are constantly updating and resubmitting NORAD's initial plans. It takes another 16 months for Congress to approve the design and funding of this underground megastructure and jumpstart the construction process. Once the green light is given, military officials stage a highly public groundbreaking ceremony for their top secret fortress. This is a message to the Soviets that the U.S. is taking the threat of nuclear war very seriously.
There was no secret. What was secret at the time, and remained secret really up until the 1980s, was exactly how hardened that facility would be. What kind of a nuclear blast could it survive?
On June 16, 1961, top military officials detonate the first blast. 3 stop-and-go years after NORAD's preliminary design, construction finally begins. It starts with a mammoth dig. A crew of just 90 workers have 1 year to carve out 5 acres and remove 700,000 tons of granite for 2 main tunnels and 7 60-foot-tall caverns, equivalent to 5.5 stories. These holdout chambers will become the protective shell for NORAD's 12 interlocking staff buildings and 3 industrial structures that include a power plant. Total size, 104,980 square feet. Each tunnel will lead to those buildings from different sides of the mountain. First job for the excavation crew, blast out the tunnels. From day one, engineers face one of their biggest hurdles: how to keep thousands of tons of rock and debris from burying the whole project. Blasting is the fastest and cheapest way to excavate granite. Miners at Norad attempt traditional blasting techniques, where dynamite is heavily packed into drilled holes. But soon realize this method risks fracturing and loosening the rock. In the worst-case scenario, the cavern ceiling could come crashing down on top of them. Crews must develop a more controlled way of blasting that keeps the walls intact. Dr. Paul Worsey is a blasting expert who consulted on the Norad megastructure. Worsey shows how the traditional blasting method used at Norad can trigger a rock wall to crumble and cave in.
All these fractures here are blast-induced, and it's really loosened up. I can even pull the material off with my hands quite easily. Now, if I could do that with a steel bar, just imagine what the shockwave from a nuclear weapon could do.
To avoid a cave-in, NORAD's explosives team used a new technique developed in 1956 called smooth wall blasting. Miners first calculate a blasting pattern by painting a series of arched lines on the granite walls. Holes are then carefully drilled along those lines and packed loosely with large sticks of dynamite. Timing is crucial. Each arch must be detonated from the inside out in a precisely choreographed sequence. On the outer arches, the rock shears off cleanly, leaving behind a smooth wall. Dr. Worsey demonstrates Norad's smooth wall blasting technique. With everyone at a safe distance from the site, it's countdown time.
Fire in the hole! 3, 2, 1!
The result, no collapse.
A nice, fairly smooth wall. There's hardly any cracking on holes at all.
Fewer cracks mean a more stable wall, which is exactly what Norad's blasters and engineers finally achieved at Cheyenne Mountain in the fall of 1961.
If they had not used these very innovative, carefully planned mining techniques, blasting techniques, the chances of having a facility that would survive a nuclear blast would have been minimal.
The excavation crews must still meet their deadline of June 1962. Blasters work in 3 shifts around the clock, 6 days a week. They must attack the mountain from both ends. The design plan calls for the 2 tunnel crews to meet at a central juncture point. There they will excavate the main cavity for Norad's 15 buildings. On the south side of the mountain, one team bores the access tunnel for Norad's ventilation system. It's 2,668 feet long and 17.5 feet high. On the north side, another team must blast out the Megastructures' main entrance. It's a shorter tunnel, 1,416 feet long and 22.5 feet high. Blasting, digging and carving out tunnels thousands of feet through a mountain takes time. The question on everyone's mind, can the command post be built before a Soviet attack? On August 13th, 1961, the Soviets start to build the Berlin Wall. 3 weeks later, they begin testing a whole new generation of nuclear bombs. For the workers at Norad, it's a race to deter a hostile superpower. Just 3 months after their start date, workers hit a milestone. On October 7, 1961, crews from the north and south tunnels meet. Together, they've carved through 4,675 feet of solid granite. It is a monumental achievement. Yet the tunnels are just the road to the main event. Digging out Norad's 7 central chambers. It's the toughest job so far. The crew has just 8 more months to finish the entire excavation phase of the Norad megastructure. A daunting task. But in the heart of the mountain, where those chambers are being hollowed out, engineers hit another major obstacle. Rock boring samples of the granite reveal a critical flaw in the cavern's roof that threatens to derail the entire multi-million-dollar project. Megastructures Norad will return. We now return to Megastructures Norad. October 30th, 1961, the Soviets test the most powerful atomic weapon ever built, a 57-megaton Tsar Bomba. Nearly 4,000 times more powerful than the bomb dropped on Hiroshima 16 years earlier. The blast has repercussions halfway around the world. At Colorado's Cheyenne Mountain, where engineers are building a top-secret command post secure enough to survive a nuclear blast. Working around the clock, construction crews have carved out more than 6 million cubic feet of rock for NORAD's 7 central chambers. But 3 months into the dig, engineers uncover a dangerous weakness in the mountain's geological structure. Huge fractures above the 3 main chambers could cause the entire cavern to collapse from the vibrations of a small earthquake. Engineers must address this new risk or terminate the entire project. It's back to the original blueprints and a radical proposition. Engineers decide to rotate the chambers 70 degrees and reposition the entire excavation project. In this new design, the cracks over the future buildings are now shorter, minimizing the effects of an earthquake or nuclear blast.
If they had not changed from the original plan for that portion of the excavation, it's likely that A, you would have had problems with caving rock, or B, if there had been a nuclear attack, the vibrations to the entire mountain would cause that to collapse.
With the revamped design, construction crews are now ready to carve out the 5 reservoirs. 4 of the reservoirs will hold a total of 6 million gallons of water, enough to fill more than 20 Olympic-sized swimming pools. A 5th reservoir will hold 500,000 gallons of diesel fuel. The surplus will run the 6 generators that provide Norad's power. With the reservoirs completed, construction crews are just a few months away from their June 1962 deadline for excavation. But soon the mountain's natural elements present another challenge for Norad's blasters. Engineers discover that large sections of the mountain are filled with water. So much, in fact, that miners can't possibly pump it all out. Too much water is a nightmare for blasters, creating fractures in the rock. Miners have no control over the way fractured rock explodes. Miners are forced to find another type of explosive. They try out a compound called slurry. Made from ammonium nitrate, slurry can be molded to fit any crevice, so it can fill a hole that is cracked. But blasting away tons of rock weakens the mountain structure. Engineers decide to secure Norad's unstable granite roof with giant steel rods called rock bolts. Measuring from 6 to 32 feet in length, these metal dowels will provide critical structural support.
Rock bolts are really important in tunneling because they're a method of stabilizing the roof. We actually pin loose pieces of roof to stabilize them.
Workers install the steel rods into the walls and ceilings of the chambers. The tip of the bolt has an 8-inch split that holds a steel wedge. Compression drives the wedge into the steel rod, spreading its tip and anchoring the bolt against the surrounding rock. Crews insert bolts 4 feet apart throughout the chambers and tunnels. Each bolt is tightened against a steel plate on the surface of the rock. As miners continue to carve out more chambers, they uncover another natural element that is weakening the rock cavern around them. Volcanic rock called basalt. Softer than granite, basalt will deteriorate and fall apart when exposed to air. Miners decide to spray the rock with a concrete mixture called gunite. It hardens into a solid wall that prevents the granite from deteriorating. With all these unexpected complications, the construction crew struggles to stay on schedule.
People were working 6 days a week, basically around the clock, and they knew that national defense, possibly national survival, depended on doing this job quickly and doing it right.
Finally, on June 18, 1962, just 2 days after their deadline, workers finish the dig. Phase 1, excavating the mountain, is complete. Almost 1 billion pounds of rock had been removed from Cheyenne Mountain. Enough to fill 23,000 dump trucks. 8 months later, engineers are ready to start Phase 2 of this monolithic megastructure. Constructing Norad's 12 personnel buildings and 3 industrial structures. 6 generators and a complex ventilation system must also be installed inside Cheyenne Mountain. But their plans are suddenly turned upside down by unexpected fallout from a dangerous new weapon. Norad will return on Megastructures. Welcome back to Megastructures, Norad. July 1962. Construction crews working 2,000 feet inside Colorado's Cheyenne Mountain have carved out more than 5 acres of granite to make way for one of the most important megastructures in military history. The Norad Mountain Fortress will be America's first line of defense against enemy threats. Phase 2 of the project is ready to begin. Engineers have already designed 15 buildings that can withstand a nuclear blast. But new advances in weapons technology are threatening to neutralize the whole project. On July 9, 1962, more than 200 miles above the Pacific Ocean, the U.S. detonates a high-altitude bomb in a nuclear weapons test. An unexpected byproduct of this explosion is a newly discovered phenomenon called an electromagnetic pulse, or EMP. An EMP generated 200 miles above Kansas could cripple the entire United States by preventing electronic devices from functioning. And NORAD depends upon electronics operating around the clock to successfully accomplish its mission of surveillance. Back at Cheyenne Mountain, engineers realize that thousands of feet of granite offer zero protection against an electromagnetic pulse. The one object that will ward off the destructive pulse is metal. Like a lightning rod, metal directs the electromagnetic pulse to the ground. But shielding all of NORAD's wires and computers in metal is impossible. A single gap in the shield, and the pulse could short out the entire complex. Just as engineers prepare to erect NORAD's buildings in February 1963, they brainstorm the solution. Construct the buildings entirely out of metal to ground the path of the pulse. Thick steel walls are brought inside the structure in sections, the only way to fit them through the tunnel opening. After they're inside, they're welded together at the seams. These steel walls will protect NORAD's sensitive electronic systems by transferring an incoming electromagnetic pulse through the metal to the ground, where it will be absorbed and neutralized. Actual construction on NORAD's steel buildings starts in March of 1963. But 7 months later, the engineers hit another wall. They determine that a geological fault in the roof of the main chamber will not withstand a nuclear detonation. They thought this problem had been solved when they pivoted the planned structure almost 2 years ago during the excavation phase, but they were wrong.
Even though they reoriented the complex, there was still a crack over a part of that complex, and that caused a great deal of concern.
Under this crack is the proposed site of NORAD's most important building, the Command Center, home to crucial monitoring and surveillance systems. So engineers come up with a new plan. They will install a giant concrete shell, 50 feet in diameter, just inches below the main chamber's granite ceiling. Its purpose? To protect NORAD's future 3-story command center from being buried by tons of crumbling rock. The enormous dome, ranging from 4 to 14 feet thick, is made from steel-reinforced concrete. It will be supported by 4 massive 3-story high concrete columns. It's so large that it has to be fabricated outside the mountain and transported through NORAD's tunnel entrances in pieces. Workers use hydraulic jacks to reassemble it inside the mountain, lifting it into place on top of the columns. To stabilize it further, the dome is fused to the cavern ceiling. 6 months later, the dome is assembled and in place. The construction of NORAD's main buildings is now the top priority. But there is still another menacing phenomenon to tackle. In a nuclear nuclear blast, the mountain would transmit shock waves directly to the buildings, injuring people and damaging sensitive computers. To combat these waves, engineers come up with their own version of shock absorbers. Giant springs 3 feet tall, nearly 2 feet wide, and weighing half a ton each. 1,319 springs will protect NORAD's buildings from any shock wave. No other structure has ever employed such an innovative shock absorption technique. It's a first in engineering history. Step by step, work on the rough steel structure of NORAD's interior buildings continues. When complete, each building will be interconnected, forming a basic grid pattern. It is inside this building, the Command Operations Center, that technicians will eventually install the brains of NORAD, its global surveillance system. In adjoining buildings, workers construct other features of this megastructure, including a medical clinic and convenience store. It's April 1964. Workers are 14 months into phase 2 of the project, NORAD's self-supporting city. 15 buildings are complete. Crews now begin work on the support systems. First, they build the power plant that will run the entire command post. The guts, 6 turbocharged diesel engines, the same kind used to power a battleship. Together, they can generate 10 megawatts of electricity, enough to power more than 1,000 households. Next, crews load fuel and water into the 5 reservoirs they've already carved out. One reservoir holds 1.5 million gallons of water for drinking and cooking. It's been 3.5 years since NORAD's first official blast of dynamite. During this time, workers have overcome all kinds of obstacles. But the NORAD facility still lies vulnerable to one lethal menace: radiation from nuclear fallout. With plenty of brawn, it's time to add the brains. NORAD gets wired with state-of-the-art technology. And now, the conclusion of NORAD on Megastructures. By early 1965, the first 2 phases of the NORAD Command Center are near completion. With tunnels, interlocking buildings, 4 water reservoirs, a fuel supply reservoir, power plant, and ventilation system. Before the 3rd and final phase can begin, installing the technical equipment that will be the brains of this military megastructure, one last detail must be addressed. In the event of a nuclear explosion, damaging shockwaves and thermal radiation can enter NORAD through 3 routes: the air intake delay ducts and the 2 tunnels. The tunnels are designed as blowaway areas. Shockwaves would travel in one way and out the other, but the air ducts lead directly into the NORAD complex. If a thermonuclear shockwave gets through these ducts, it could destroy the buildings. The solution? Create a safeguard called a blast valve. NORAD has 58 of them, weighing in at 8,500 pounds each. Inside this 4-foot wide tube is a movable seal that opens and closes the valve. When a nuclear blast goes off, it creates a change of air pressure. In less than half a second, NORAD's blast valves will automatically seal the air intake ducts leading directly to the facility. The contaminated air is then forced to go through a filtration system called a CBR filter.
The fresh air that comes in is forced through those filters where we ensure that no radiation, no chemical agents or biological agents could get through into the complex.
There is one more weakness at NORAD that engineers need to address: the entrance doors into the complex. Located along the tunnels, they must be able to seal off the facility during a nuclear blast. For this, engineers borrow a different design. The inspiration for their solution: a typical bank vault door. Engineers create a mega version they call a blast door. It's 3.5 feet thick and weighs in at 50,000 pounds. Hydraulic motors push a series of steel pins into the door frame for a lock more secure than any bank vault. Like the blast valves, the blast doors close automatically when a nuclear explosion creates a change in air pressure. With a lockdown system in place, Norad is now equipped to seal itself off in the event of a nuclear war. The complex will stock enough water, fuel, and food, including 72,000 meals, to continue its mission for a full 30 days without any help from the outside. By late fall 1965, all of NORAD's 15 buildings are assembled. The first 2 phases of construction are completed. It's time to launch the final phase of the project, installing the early warning and surveillance system inside the command center of the new NORAD megastructure. Although the details of this intelligence are classified, NORAD makes no secret about its primary mission: to track aircraft and missiles launched by known or suspected enemies. It's up to those manning this megastructure to identify any airborne weapons entering North America's airspace. Phase 3 has been a massive undertaking. Computer experts are in a constant race against advancing technology. But by the start of January 1966, the job is done. A Philco 200S computer is installed at NORAD's Command Operations Center, one of the fastest scientific supercomputers of its time in the world. The brains of NORAD are up and running at Cheyenne Mountain. On April 20th, 1966, more than 6 years after construction began, the NORAD Command Center closes up its old headquarters in downtown Colorado Springs and kicks off operations inside Cheyenne Mountain. The entire project cost $142 million. That's equivalent to more than $18 billion today. Hundreds of civilians work at NORAD alongside 600 enlisted personnel from the U.S. Army, Air Force, Navy, Marines, and Canadian military. From airmen to brigadier generals, NORAD is busy day and night, fully staffed in 8-hour shifts, 7 days a week, 24 hours a day. The cafeteria serves 4 meals a day, including one at midnight for those working the night shift. The underground work environment is significantly different. There are no windows at NORAD. In fact, the entire complex has a no-frills design that's been compared to the lower levels of a battleship.
There are people who find it very difficult to work in this environment. If you never see the sun, if you never feel the breeze, never see changes in temperature, it can be very difficult.
The government has gone all out in outfitting this megastructure.
NORAD was a statement to the world, in particular to the Soviet bloc, that the United States could be attacked, but they'd reply with a big stick.
For 20 years, NORAD scans America's borders for airborne attacks from the Soviet superpower. Then, in November 1989, the U.S.'s greatest foe and NORAD's primary reason for being comes tumbling down. The Soviet Union, the enemy that moved North America to build an indestructible fortress, collapses. And the Cold War officially comes to an end.
Many people thought that NORAD, with the Cold War being over and there's being less of a potential possibility of an attack from the outside, that NORAD was obsolete.
Okay, stand by.
But is it? As the world situation changes, so does the mission of NORAD. NORAD now expands its mission of global surveillance to include missile threats from rogue nations like North Korea and Iran. Soldiers watch and warn of missile attacks from terrorists anywhere in the world. It's a mission that depends upon a complete overhaul.
It'll be like a Volkswagen. It always looked the same for years and years, but they kept fine-tuning the engine. They would change some things on the inside, etc. Well, that was what they said about the mountain. Well, the mountain will always look the same from the outside, but we'll be fine-tuning it and be changing it on the inside to adapt to current needs.
Needs feats that require the brains of Norad, its top-secret supercomputer, to be constantly upgraded and updated. Even though NORAD's surveillance systems are powerful enough to detect a 4-inch-long object in the Earth's orbit, that did not prepare the command post for the tragedies of September 11th, 2001.
On the morning of 9/11, we received intelligence that there might be an airliner specifically headed for Cheyenne Mountain. We closed the blast doors that day.
The attack on NORAD turned out to be a false alarm, but the terrorist attacks of 9/11 forced NORAD to update its role and mission once again. It's imperative they revamp the center to prepare for, and more importantly, prevent unpredictable acts of violence from future terrorism.
The threat has become much more asymmetrical, and by that I mean terrorism is out there now. The threat is no longer a bear, but it's a ball of snakes.
On March 4th, 2005, NORAD officials unveiled their largest renovation since the mountain fortress first opened in 1966. Their newly refurbished command center. It was rebuilt within the existing rock chamber, carved out more than 4 decades ago.
What you're about to see will show you we no longer need Hollywood to make our mission appear state-of-the-art and functional for its missions. Ladies and gentlemen, it's our pleasure to announce
We are now officially open for business.
This $15 million project took 17 months to build and doubled the command center size. In today's post-9/11 world, NORAD is a state-of-the-art facility that now features the latest in detection, surveillance, and warning technology.
Any missile that's launched anywhere in the world will be detected by satellites and possibly by radar systems. And they're all tied into one global warning computer system that we're able to monitor here in the Missile Correlation Center.
Space Control Center Major Olden are coming up with this outstanding first Space Patrol Squadron morning.
As a central command headquarters, NORAD's job is to assess the threat and coordinate the military force necessary to intercept or destroy the enemy. Officials now keep an even closer watch over the skies above the homeland. Every day, more than 10,000 aircraft are in the air over the U.S. at one time. Ever since the unforeseen airborne attacks of 9/11, any one of those planes could be a lethal weapon.
We are the agency of last resort, and we really don't want to be involved, and if we are, then it's gone too far already. That said, a quiet day here is a good day for us.
NORAD's mountain fortress was built to pass the ultimate test, to survive a nuclear catastrophe. A test it may never face because it fulfilled its mission so well.
This is the most secure place you can be anywhere in the world.
A remarkable claim for a stronghold almost 40 years old. The engineers who designed it had a unique vision: to build a garrison where people could see out into every corner of the world, but where no one could see in. Hidden beneath 2,000 feet of solid granite, this military complex has faced many challenges over the years, including the rapid progress of computer technology, the unpredictable nature of an almost 2-mile-high mountain, and the persistent threat of random acts of terrorism. In the end, NORAD has kept pace with the cutting-edge advances in global warfare. This modern military megastructure keeps a constant watch over the world and America's safety.